suggest you just follow my script and you just use that. So what I'm going to do, I'm going to rebuild this exactly as it is instead of using this one. But we need to use exactly the same input. So instead of point, we are using 0, 0, 0. So that's better. But you have to make sure that your geometry is built at 0, 0, 0. So 0, 0, 0. So we are going to have G as a geometry. And PA, we need 4 input. Okay. Let's just follow that. PA, PA, PB, PB. Point 3D, vector 3D, point 3D, vector 3D. Okay. And we use this input here, this input here, this input here, same, this input here, and this input here. Okay. And we are going to have output also. I'm going to call it G. I'm going to also output this X as a transform. Okay. And I'm going to plug this. I can do this later. Okay, I'm going to hide this and I'm going to start build the transform step by step. So firstly, we need to build something called transform. Transmove. So there is 3 transform you need to do: move, rotation, and scale. Transform, translation, and PB to PA. Transform, rotation. So you don't need to know how to do this from scratch, but after these few lines, you will be able to control the transform a lot better. Transform, rotation, DA to DB in PA. Transform, scale, transform dot scale from PA to DB length divided by DA length. So this is translating or scaling according to the scale of the vector. Final trans is transmove times transrotation times transscale. And only if G is not null, G might be an invalid name, so we might need to change it. Final trans, Control V, okay, and G, because we made G here, so you cannot use G here. So I'm going to change this to something else. So I'm going to change this to input G. So change the input G to C, Control V, input G, trans, and finally G is input geometry, and X is final transform. Okay, so if you compare now, this and this does exactly the same thing. But what's cool now is that you can actually control a lot more. So for example, you can say, I'm not going to do any scaling. So you can just by deleting the scale vector, I'm going to hide this and hide this. So it's so much easier to do much more free control. Yeah. But what we are going to do now is something a bit more sophisticated. So in 3D, okay, what we want to do is, so they are great, but I want all of them to still keep that randomness, but have them all like towards upwards. So there is no translation in the z-axis. So you can actually control that by adding few more lines here. So that is from here. It might doesn't look very intuitive though, but once you have this code, you can have much more freedom. So you need to make a plane. So new plane is PA vector 3D 1. So towards up. So it's an up plane, and we need to rotate this plane, calculate the rotation of this plane from a random rotation to a up rotation. So transform this plane to as if the final trans. And I'm going to calculate a new transform. Control transform rotation, and my transform. So my plane dot z-axis, because I'm going to constrain that z-axis to new vector 0, 0, 1. So that's towards up, and my plane dot origin. So from that origin of the plane. So if my input plane geometry is not null, meaning it exists, so my transform rotates it back to that up axis. It does another rotation. And my plane also gets transformed together if you want to have it visible. But this line is actually unnecessary. So these three lines was a process to calculate the new transform. So let's see what's vector cannot be found. Vector 3D. Okay. So you can see that now they're holding up. So even if they are like whatever going up or down, you can see that they are all snapped to up axis. That's pretty interesting. Yeah, so maybe this sounds like a bit redundant, but that's quite precise how you are snapping things and orienting things to add more control. So you can modify this further. So I kind of baked it. You can actually use this to generate your further geometries. So I'm not gonna take it. So save. I'm going to use this to preview and hide this. Okay, that looks pretty interesting. And once I bake this to last, you can start to look at this and understand it as more architectural scale. You can start to add some slabs, for example. And clicking plane. Some interesting. Oh, I didn't know grasshopper can also. Cool. Understand it more like architectural geometry, start to build something. Okay, I think that's pretty much it for this exercise. Oh, yeah. Can I spend a little bit more time to show you the plugin? So basically, once you have that plugin, set it up. So this one I can put it on the side or whatever. So let me bring that up. So okay, so if you go to example tutorials, and there is a thing called blocking as C#. This is more easy to use. So bring that up. So if this asks you to, if you have this problem, so hit on this one and go to your libraries folder where you installed this thing and just point this to the SDP GHA file and this should work. And once this is there, why is this still showing? Okay. Hide. Okay, once this is there, is 3D true or not? Reset true. Play. Reset false. And this gives you a flocking behavior. It still gives you location and velocity. So you can use these two values to still orient your geometry, for example. So you can easily, so this is the count. So I don't want to crash. So maybe let's reduce it to maybe something like 20 for now, or 50. I'm being too careful, but okay. So I'm going to just copy this, copy these lines, these, and even this one, Oh, I can leave it there. Okay, Control C, Control V. And I just need these locations here and velocities here. Of course, it's big, but that's okay. One trick you can do is if you are lazy to go back to the geometry, you can change this to something big. Then it goes smaller. So that's how you can also orient any geometries. Of course, you should have more fun with it. So when reset is true, it just resets for a random position. So this should be false in order to start simulating. Yeah, and then you can make this into 2D as well. You can increase the number to you can easily make some cityscape, for example. And yeah, and in this one has a you need things called project points to mesh, project mesh to mesh. So you can project this mesh to something. Like you project all these points, give a target direction at Z. And if you have some kind of terrain geometry underneath, for example, oh, I still have my clipping plane. So rebuild to can you can make your own like terrain, for example. And you mesh this. Mesh. So you have a mesh. If you have a mesh, you can project your points on the mesh. And you can actually use these points instead of the actual points. So you can make some kind of interesting landscape design, for example. Okay, so yeah, I hope you can have fun with it. And this one is actually, you can modify where you set the starting point and stuff. So if you go to the example files, set starting location, C#, if you open that, you will see that this was like setting the starting position to somewhere specific. And they're all going towards somewhere also specific. And you can see how I was coding that in that example. So you can compare this code. So this is the simplest code. So if you want to make their starting point and add more specific function, you can open this one. This you can ignore this one. So download and install or ignore, doesn't matter, because this one creates the pink trail. I don't need it actually, so don't worry. But you can actually see how this is adding few more lines to set where they start. So you can also change few more things. And if you have more functionalities that you want to add, you can also contact me to add that example, or you can also try by yourself. Okay, I hope it was useful. Maybe one last thing I want to say is that if you want to check, this is my widget. If you want to add me, and you saw obviously my website. This is our program that we are going to teach. So if you are interested in pursuing further academic career with us, you can consider this program. I'm running 2 other workshops in Korea and Shenzhen in coming week. In 27th July, in 2 weeks time. So if you're interested in, you can also see if you wanna apply. This one is in also online course, but dealing with social issues in urban design. That's going to be in August. Yeah, so if you're interested in there further workshops and everything, if you're everything is on my website. So if you go to my website, I always have in the news page, I post all my upcoming workshop information here. So if you are interested, you can also keep track on what I'm doing. Okay, do you have any question?
So
There's a question.
Pingyang is asking about the image when he opened the grasshopper.
It shouldn't be a problem. Are you able to run still? Okay. Yeah, okay,
Well,
yeah.
Yeah,
I
have a question
troubleshoot.
for you.
Okay.
So so the script you taught today, compare this one to some like kangaroo physical system or some physical system in Maya. So are they sharing the same basis logic, or they are totally different method to do the moving or something like that?
So physical system is slightly different. Yeah. So basically, physics are particles, and
Yep.
what you coded today is agents. So the main difference is particles have environment parameter, wind, gravity, and everything. So the particle itself is not smart, doesn't make any decision. But agents, it's more like insect. They make decision and they do collaboratively do something. So you can actually code this for like modular robots, for example. Yeah, but particles are different. Particles are like dust particles. They're just going like sand, doesn't think, isn't it? It's like blown by wind, blown by the environment parameter.
All right.
Does it make sense?
Yes, makes sense.
Okay.
Cool. So the files you operate today, so are you going to upload to the folder, or it just doesn't matter?
Okay, so I only need to share with you one file, right?
Yep.
Which is let me share it now. So
Okay, cool.
So that's this file. Sorry, that's this file, right? The one we built today. So I will save this, close it, and that is this file. Can I send you now, maybe
Yeah,
on
sure.
chat.
Yes.
Let me
It's okay.
try like this.
Uh-huh.
Did you get it?
Yeah. Yes. Yeah, I think so.
Great.
Uh-huh. So yeah. So thank you, Sumin, for today's lecture from
Cool.
beginners to masters. And
I hope it was helpful.
yeah, it's really helped when someone want to learn the basics from the beginning to very fluent about the operating the scripting. Okay, so anyone has some question, please type in the chat. Maybe.
Probably only Ping Yang was following.
Yeah.
Everybody else was just.
He's really hardworking now.
Yeah.
Yeah.
Okay.
He
Cool.
he used Python. He just told me before. Yeah. So C# is the most difficult one, right? I think.
No.
No. All right.
They're similarly well developed for users. So I'm not good coder. Like if I go to like more advanced one, I cannot do it. But this one is easy enough for me to understand.
So,
Okay. Anyways.
Okay.
Yeah. Hope you guys enjoyed, and yeah, hope we can see each other again sometime.
Sure.
I haven't seen any of your faces, but yeah, I hope to see you again.
All right. Thank you.
Okay.
Thank you
Yeah,
so much.
enjoy your rest of the workshop.
Thank you.
Bye.
I'll email you all the image when final or something.
Oh yeah, that would be great. Can you also share the recording?
To you, right?
Yeah, this recording.
Yeah, sure.
Okay, thank you.
Okay, maybe later I will email you or
whenever. Yeah, no rush.
Okay. Okay, cool. Okay.
Thank you.
Thank you. Thank you,
Bye.
Sumin. Bye.